Last speaker in this morning session on sustainability is Don Matthews with Pavement Recycling Systems, and he's going to be talking about RAP in preservation treatments. So
I'm going to talk about using RAP in asphalt, reclaimed asphalt pavement in pavement preservation. Let's talk about what we know. One is asphalt is the second most recycled material in the world, only behind water. And it's a valuable aggregate. You know, some of the best the aggregates we have are in the roadways, and it works really well in hot mix, but some areas limit the amount that can be used in hot mix, and sometimes it's not cost effective. If you have some agencies that some allow it and others don't allow it, the hot mix producer's not going to look at it as a consistent method. So because of that, the limitation, we keep having buildups in different areas around the country. We're getting, as Jason said, mounds and mountains of RAP. So as Jason touched on, some of the historical uses have been shoulder backing, just laying it down in yards, haul roads, dust control, cross miscellaneous space. But these are really a poor value for such a valuable asset. And there's no need to squander it, or no need to squander it or virgin aggregate, because in RAP, in many cases, outperforms the virgin materials. It's neutrally charged, so when we use it with emulsions, we don't have a problem whether it'll work. It's really cost effective. It's environmentally smarter. And when we use it in like seals, it tends to stay black a little bit longer. I'm not going to say it's a black rock because it does oxidize out, but it tends to stay black longer. So today what I want to talk about is some alternative uses. One is RAP chip seals, some RAP and slurry microsurfacing, combining the two into cape seals, and then I'm going to touch a little bit more on what Jason started here about cold central plant recycling. So when we're looking at RAP as a chip aggregate, you'll find when you crush it down that you have different components of it. Some, it's almost the original virgin rock, all the way to the end where it's just a conglomeration of different aggregate sizes. And it'll vary depending on the type of source of the RAP. So what we do is when we look at our RAP gradations, these are the two gradations we make out of California, and we use it quite a bit. I will tell you right now that when we have an agency switch over to RAP aggregate or RAP slurry seals or RAP microsurfacing, they don't want to switch back. They like it better, they like the looks better, they like the performance better. The only time an agency will ever switch back is just simply from a cost standpoint if they have a job that's way out closer to a virgin aggregate source. But if they can get the RAP, they actually specify it and do it. So we segregate it into two types of RAP chip seals, and these are the two we do, what we call our medium 3/8 inch size, a little finer, our 5/16 size. On this slide, you'll notice that we do some kind of standard testing. Always look at the durability. We also look at cleanliness value, but we only report it only. And the difference versus the RAP is when you are doing virgin aggregate, you want to make sure it's really clean so that the rock can bind to the asphalt. Well, the dust in RAP chip is actually asphalt. So we get extremely good binding to the asphalt. And so we actually, sometimes people go, oh, wow, this looks dusty. But the dust is actually asphalt. We don't care. What we do want to care about is if we're using an emulsion based, we'll wet it down so it'll stick to the emulsion a little bit better. If we're using an asphalt rubber, though, it's just the opposite. We want to dry it out so it sticks to the asphalt rubber better. But again, the bonding is excellent. So here's just an example. Here was a 3/8 inch chip using an asphalt rubber chip seal. Here we're just applying it with a polymer modified chip seal, 5/16. First job we did, and anybody who flew out way back when, we actually traveled on this road when we had the recycling conference in California back in, I think it was 2009, I think it was. But we had done a chip seal for the San Bernardino County. They tried it, they were first job, and we did it with 5/16 inch chip. And you look at this road today, 12 years later, it's still with a lot of traffic. There's a cement plant. It looks really good. People ask me why we only did one side of the road. Well, that was San Bernardino County on the right side. On the left side was Riverside County, so they didn't do that other side. So we can do it with a scrub seal, which is essentially where we're going to take the emulsion. We use brooms and we scrub it in the cracks so it acts as a crack filler and a chip sealing at the same time. We use an emulsion with RAP chip. County of Los Angeles has gone 100% exclusively to RAP chip and RAP microsurfacing. They do some projects that I wouldn't say recommend a chip seal. There's a lot of fatigue cracking, and they're essentially just trying to buy time with it. So they do a scrub seal. You can come in, you can see that actually some of the cracks, you can actually see the cracks, but the chip seal with the RAP stays into the cracks, and they get, 6 years later, they're still happy with the performance. It may not look as good, but it's definitely sealing it up and buying them time. What's the difference between RAP and conventional aggregate? Well, our typical shot rates for RAP aggregates are about 0.28 to 3,200 gallons per square yard for a 5/16 and about 3,200 to 3,600 gallons for a 3/8 mix. We start off with the same shot rate for the RAP. We don't get any benefit of the asphalt. But the one thing that we do look at is the penetration on the residual asphalt. If the penetration is high, then we're going to reduce our shot rate down because we get a little more diffusion, we get a little softening of that asphalt, and that RAP kind of blends in a little bit more with the emulsion that we put down on the roadway. On the other hand, we also look at traffic. If we get high traffic, mostly we're worried about high traffic on chip seals, dislodging the aggregate. It's just the opposite with RAP. If the traffic is high, we actually reduce the shot rate. It needs the asphalt into the emulsion, and it softens it up faster. So we found, like on one job where we actually did the same shot rate, we actually got a little bit of the bleeding on there, and we reduced the shot rate, and the traffic actually needed it in, and we could reduce the emulsion, actually saving some money. Right now, until we do additional research, we're not going to look at doing a double chip with RAP. So if it's a double chip, we do typically one or the other layers, depending on the agency's preference, one with conventional aggregate, one with RAP. We just don't want so much oil and so much asphalt in that existing roadway. We have no problem doing a RAP cape seal with a RAP chip seal and a RAP microsurfacing on top of it. So when we come to RAP aggregates, type 2 slurries or microsurfacing, we use conventional equipment. And now, because we're getting down finer material, we have less conglomerations. It's more closer to the parent aggregate. There is some, I'm not going to say there's not, and I'm going to show you some gradations on that. So this is a typical type 2 RAP aggregate pile that we just place on the job. So the differences, for RAP aggregate for slurry or microsurfacing, we don't get as many fines. The fines are locked up in the asphalt, so it's a little bit coarser on the RAP gradation than it is on a typical slurry. We don't need those fines to help with the bonding. It's already within the aggregate itself. We do have an issue with clumping. So when we make the material, we don't stockpile as long because the RAP will start sticking together. And if we make it, like I have right now, a whole bunch of the RAP slurry made, I'll just run it over a screen right before we send it out. And it breaks down pretty easy, but we want to make sure it doesn't clump out in the field. We do use a rubber tire on every slurry. We roll it. It helps start kneading the RAP and the emulsion together. We also add 3% latex modified. We modify the emulsion with 3% latex. The emulsion, or I should say the polymer, actually helps binding everything together until everything starts melting together. If you look at our typical type 2 gradation, you're going to see that the unextracted RAP, we're down to about 2 to 12%, passing the number 200, which is a little off from the ISSA type 2 slurry specification. But when we extract it, we're really close to being into the ISSA slurry requirements. We do require that at least 6.5% residual asphalt is in the RAP. We do that to make sure that it is pure RAP, that we have a lot of the binder in there. We don't want some dirty material in there. We require a sand equivalent, and we do a LA Rattler on all of our RAP to make sure we have a good durable material. The one thing I want you to note here is we said we use a rubber tire and we add 3% latex, and everybody goes, oh, well, that'll increase the cost. Well, no, because of the RAP, when you're looking at that in slurry, you don't need a part of your emulsion to just go to coating the material. It's already coated, so it goes to more bonding. And because of that, you can see with RAP, our emulsion contents are typically 10 to 14% compared to our conventional aggregate that's 12 to 18%. So we actually use less emulsion, and therefore the cost with RAP is actually slightly lower than it is with conventional aggregate. And you get the rubber tire roller, and you get the additional latex. We do look at a residual AC that we want a high residual asphalt content. Any conventional equipment can be used. It's not like you need special equipment. We do modify the essentially vibrator plates. We move them up a little bit to give a little more room. But we use our typical slurry or microsurfacing equipment. And this is what kind of the agencies like, is when you compare a year later or 5 years later and you go down and you look at the streets that were done with conventional aggregate versus RAP aggregate, you just go, you know what, the RAP just kind of looks better. It's not like it's a whole lot darker, but it's a little bit darker. The cracks seem to be filled in a little bit better, and that's why they like it. Plus, it's just environmentally so much more sustainable. So how do you use RAP? Well, one is you can just require it. We have some agencies that say you can't use conventional aggregate, you must use RAP aggregate, period. They specify it. Others just say you can use it as a substitute. You can either use the RAP gradations, or you can use it as the conventional. It's up to you. We do it several different ways. We have a RAP aggregate central production facility where we go ahead and bring in RAP from all our milling jobs, process it out, make it to sell just to competitors, to whoever wants to buy it. You can see that we just store our 5/16 inch chip made from the RAPs. Every day you could come in and get some of those. Or what we also like to do is we do what we call our urban quarries. And essentially we find RAP piles and we go to them, or we have sites that we bring the material in and we process it and make it on site. California DOT, Caltrans on one job said, hey, we got a bunch of RAP, we want you to come out and we want to crush it down and use it. And so we ended up making both the chip and slurry simultaneously, came out with a plant, made both of it, and they did a Cape Seal over Interstate 10, which is a huge traffic volume. I'm going to show you an example of LA County. It's a short video that they did, so how they did it for essentially for a Cape Seal where they used RAP chip and RAP slurry. Yeah, so they had one project here. And you can see the kind of urban sprawl we have. It was about a 2 million square foot job, and they wanted to do a Cape Seal with the RAP chip and RAP slurry, and they had some areas that were really bad. So what they did is said, hey, listen, we're not going to go over there. We did just a little few dig outs first. We milled it out. And then just replaced it with asphalt concrete. So just the real bad subgrade areas, we did isolated dig outs. There were probably about 15 of them throughout the whole project. And then the next step is LA County has gotten to the point, before they do any slurry or any chip, they micromill the road. They just absolutely love it. They think they get better bonding. They can get they can re-get the surface back to where they want. They remove any other layers. And they think it's just a cheap investment to go ahead and micromill the roadway prior to doing their chip. So you can see where they micromilled over the patch and some of the cracked areas. And then we do a scrub seal, which is here we're scrubbing the emulsion in so it acts as a crack filler at the same time. And you can see the RAP chip. You can see a lot darker when we're placing the RAP chips. Now, we'd never do a chip seal in an urban environment like this, so they'll come back through after that and do a RAP slurry seal on top of it. And that's your kind of finished surface. And this is what they really started looking at. They calculated how much green gas emissions they save, their energy consumption, compared to the normal just Cape Seal. And they figured out they had a huge cost savings on it. And this is about 3 years later, just driving the roadways. So we do a lot of wrap chips, a lot of wrap slurry seals. I know it's starting to get more prevalent throughout the country. I get a lot of phone calls, people asking how to do it. I got one agency from South Dakota said, hey, they were going to do it. They called me back, said it worked real well. As I said, anytime we have an agency use wrap chip or wrap slurry, they don't ever want to go back. They just like the performance better. So Jason touched on this a little bit. I'm just going to go through another way of taking rid of those mountains of wrap in a pavement preservation option. And essentially cold central plant recycling. You got clean wrap, you got new pavements. And you can do it kind of 3 ways. You can on-site cold central plant. What Jason talked about is you mill it and just take it somewhere close and do it on-site. Or you can bring wrap from another job. And that's one of the things I want people to start thinking is if you got a whole bunch of milling from one job and you can use it someplace else, take it to the other job. Use that wrap again. And the other is where you can just have a central location where you store your wrap. So on-site, we just, prior to milling, we cold mill it, we stockpile it nearby. The nice thing about central plant recycling is you can fix the subgrade, soil cement it, or just deepen it, whatever you want to do. You can import it from one job. Here's where we had one city job taken from one, and we used it to pave a kind of industrial facility. And then we also, at the same facility that we do a wrap chip slurry, we just take in all our wrap, we segregate it, and we start using it for just whatever project we need to use. We typically size the wrap anywhere from 1 inch to a half an inch and a half. You can just use a scalping screen on it, or you can crush it and screen it all at the same time. Or what we like to do on our central facility is fractionate it, make it into a couple different layers so we can blend it back to a specific mix design. That way we can also add, if we want to, but it's very rare, we can add different materials together, and we can even add some virgin aggregate if we want to make it a very, very dense graded mix design. So we're going to mix it with a recycling agent. We either use emulsions, engineered emulsions, polymer modified emulsions, solvent-based emulsions. We use different kinds depending on where we're at. Or we can do an expanded foam. Both of them work very well. Sometimes we add a little cement. We like to add just a little cement or a little lime. Just adds in the initial behavior improvement of the material. We can also just do everything on site with a combination processing plant. This is the train we use for cold in place recycling. We normally drag this down, but we can also put stationary where it has a crusher, screen deck, mass flow meter, and Pugmill all in one. Or we can just size the wrap and bring us another, like Jason showed, another Pugmill and do it anywhere on site. So after we've mixed it, we just truck it. We do truck it. That's where it's not as environmentally sustainable as cold in place recycling. It's in the same place, but it's a whole lot more sustainable than trucking it further to an asphalt plant and bringing back hot mix plant. We do sweep and tack before we do any cold central plant recycling to get better bonding, and then we just pave it. And you can pave it in wherever you look. If you look on the picture on the lower right-hand corner, that's actually Wilshire Boulevard in Beverly Hills. We did a combination cold central plant and cold in place recycling on that. You can imagine Beverly Hills being a very liberal area. They loved it. They loved the recycling part of it. In fact, we parked our train in about a $12 million mansion's driveway. He liked it so bad. Give you one other thing, it's not so much in this picture here where we're doing cold central plant, but you can see the cars. At one point when we're cold in place recycling, somebody measured the amount of vehicles that were coming by in a short period, and we estimated over $10 million worth of cars driving by in 20 minutes. Lamborghini, Ferrari, Bentley, Rolls-Royce. So it was, if you can do it there, what I'm trying to say is you can do it anywhere. Just compact it. Make sure you use real heavy rollers because you do get a slightly higher air void. We do apply a fog seal and sand blotter We release it to traffic at the end of each day. That's not the problem. But we want to make sure we give a little more protection in the sand blotters, just simply so the fog seal doesn't track, doesn't pick up. But you can see the traffic on there on a recycle that we just finished that day. If we use emulsion, we let it cure for a couple days, then re-roll it. If it's a foam, we don't let it, we re-roll it, but we'll both let a couple days to cure. And then we got to put some kind of surface on it. We're going to put either, depending on the traffic, either a chip seal. Most of the time we put a thin overlay, as thin as we can pave it, just to prevent that shear force with the higher air voids. So here's an example on an agency that we stripped off the AC, then we FDR. LA County likes to do that a lot. They can improve their structure. Put that down as 3 inches, then put a thin lift AC on this. And here we did about a huge auto auction. We just did cold central plant recycling, and then we put on just a fog seal on top of it for that. These are actual pictures that we're dealing with. Homes next to aggregate pits. We're running out of aggregates in California. We're barging it in or training it in from Canada and Mexico. Our aggregates, we can't open new pits. And the real thing is we're running out of good aggregate. The solution is use RAP. There's no reason we cannot use it for a variety of type applications. I'll take any questions.
Love them to death. The hot mix industry owns the RAP. And as long as they own the RAP, the more creative recycling doesn't get done. That's just the facts of life.
So change ownership. We have specifications that do both. Some that says it's up to the contractor to dispose of. It actually says the contractor, mill, and remove the RAP. So they essentially own it. They can do whatever they want. We have other agencies says no. We have quite a few agencies that started doing it because they had the same challenge. They said that the RAP shall be deposited, trucked and deposited to this facility, or it shall, or that it shall be stockpiled at, and they said the actual locations. So, you know, I don't know how it works in the Northeast, but specifications are contracts. And so if you specify where the RAP goes, because we have both. We had the same issue that people said, oh, that's our RAP. And the agency says, no, part of the contract is you will take it to this location.
In California, what kind of aggregates, like in your surface mixes, are in the RAP piles, I guess? Is there friction concerns with using it for microsurfacing?
No. I mean, we have a wide variety of it. Most of the older aggregates are good granitics, you know, some of the metamorphics, but we don't have any issue with friction or that type. No rounded aggregates. Everything's 100% crushed in our asphalt, and that's what we're using is the asphalt spec.
For chip seals, you use black rock for gradation, right?
Yeah, actually, we do too. Every time we test for our either our chips, our microsurfacing or slurry seals, we do an unextracted gradation, which is the black rock, and we make sure that's what we do to kind of do the quality control of our plant, make sure we're in spec with respect to the gradations on that. And then we do an extracted gradations, and what we're looking for is what we have. We don't really care on the chip seal so much, but on the microsurfacing we do have a gradation for it, but we also looking for the minimum asphalt content, because you want to make sure that you know, if you find that you have a low asphalt content, it means you've probably got other stuff blended on there and it's not pure RAP.
So without angularity, you check that on black rock or on a extracted aggregate for chip seals specifically?
We don't tend to have an issue with it, so we just check it on the black rock, but it's just not a problem. We're using a RAP from an asphalt that's already been crushed, and then we're crushing it again.
I noticed in those gradations that there's a substantially larger amount of -200 allowed, and you did touch on that. That's not necessarily dust. It's more trapped with the asphalt there. Now we have a major problem with fugitive dust when it comes to our chip seals. Do you ever see fugitive issues with that? And then secondary to that, do you ever see as you fractionate that you break down aggregate and actually do get regular dust that's not already coated?
Are you talking chip seals?
Either one, really.
So what we do before we do anything is when we mill it, we take it directly off. And the milling, yeah, I'm not going to say it doesn't crush some of the rock, but it typically tears the asphalt more than anything. So we screen as much as we can before. So we actually, when we're crushing back, we're going to end up crushing it a lot smaller. We don't send everything to the crusher and then screen because we're going to grind down that rock more. What we want is to have more coated aggregate. So we screen it first, and we have actually a small return coming back to the crusher on there. So we don't get a lot of it. Where we get it more is when we get the chunky asphalt, and we gotta crush that. So what we do is open up the crusher some. So we're trying to not crush as much as that. As far as the fugitive dust, we have it more when we do hot rubber because we don't add water to it on there. But when we do an emulsion, we really try to get it kind of moist so that when we're doing it, and I have more concern now with fugitive dust than the silica issues, so that we've started really monitoring plants. So we make sure that we keep the water on the emulsion way down. Up. So that it binds better and we don't have a big issue on the dust. I'm not going to say we don't have some dust on it, but typically when you do it, and we've actually grabbed, kind of like tried to collect the dust, it was mostly asphalt. Very little. When we extracted it, there was very little aggregate in it. It was, almost not even perceptible. It was almost all asphalt on it. In the cold central plant recycling.
Yeah, expressed as a percentage, how much is a little cement?
0.25% to half at max. Yeah, we're just adding it it just kind of, everything just works a little bit better. We do not ever want to switch from a ductile to a brittle type failure. So a lot of people try to add a lot more cement, and we don't like doing that. We try to add just a little and let the asphalt do all of what it's supposed to be doing.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.